Hey everyone, welcome to the Sustainability Supply Chain Podcast. My name is Tom Raftery, and with me on the show today, I have my special guest, Bryan. Bryan, welcome to the podcast. Would you like to introduce yourself?
Sure can, Tom. So I'm Bryan DeBois. I am our Director of Industrial AI at RoviSys. So we are a system integrator that is headquartered just south of Cleveland, Ohio in the United States. Though we're a global SI, we've got about 17 locations around the world and about 1,400 engineers globally. So we work primarily with industrial and manufacturing customers. In this role as Director of Industrial AI, my job really is to bring AI solutions to those industrial and manufacturing clients. And we started this division about 5 years ago, but I've actually been with RoviSys for about 23 years. In my background, I've actually got a computer science degree.
Nice. And I got to think, 2023 was a big year for AI. So, did you suddenly get really busy?
In a lot of ways, yes. Although, over that 5-year period, we really have seen a lot of steady growth as more and more of these customers start to look for AI to bring those material gains in both in scrap reduction and increases in yield and things like that. And AI seems to be the most promising tool to be able to reach that. Now, of course, with 2023 really was the year of generative AI, right? And so
Sure.
I was talking to someone recently last November about ChatGPT, and I was like, it's interesting to think about. We're really only a year into ChatGPT as a phenomenon. It was November of 2022 when it really had its big coming out party, and they got 1 million subscribers in a very short period of time and all that. And so 2023 really was kind of the year of generative AI. And so what's happened then is that a lot of customers will call me up and get excited and want to bring me in to talk to them about AI because of what they've seen with the likes of ChatGPT and DALL-E with the image generation and things like that. What I end up telling them, though, is kind of pivoting is that while those generative AI solutions are really good at solving knowledge types of problems, the reality is on the plant floor that we end up seeing a lot more operational types of problems. And there are other solutions, and one in particular that we're pretty heavily invested in is called autonomous AI, which we can talk about later. But that really is more of a solution to solve operational types of problems on the plant floor.
Okay. And I mean, I can see ChatGPT, great for writing, social copy, great for, as you said, creating nice, pretty images for you. I don't see a lot of functionality for that on the plant floor. So what is it that your autonomous AI can do that the likes of LLMs and ChatGPT can't?
Yeah. Well, and real quick, just, to talk about maybe some of the real limitations that we're concerned about with the generative AI on the plant floor is this idea, and a lot of people have talked about it, is this concept of hallucinations.
Yeah.
And the idea there is that LLMs have a really hard time of saying, I don't know. If they don't have the information, they typically will just make something up. Now, ChatGPT does a little better job of saying, yeah, that's outside of my, realm of knowledge, but it's been programmed to do that. Most LLMs will just make something up. And the problem on the plant floor, and so everyone's scrambling to try to figure out how to apply this in manufacturing, and maintenance is one of the big areas that they've looked at, because you typically do have lots of stores of knowledge and lots of standard operating procedures and lots of history there that you can digitize and then train, an LLM on. The challenge is that if you say, hey, I've got this machine in front of me and it's having this problem, how do I fix it? Even if that data is not in the LLM, it's happy to say, well, I know exactly how to fix that problem. Take this bolt and torque it to this, and you could blow up the plant. And, so that's those hallucinations on the plant floor can lead to some really bad outcomes. So we're keeping an eye on it. I think that there's still a lot of promise there, but there's still a lot of research that needs to happen. Now, if we look at autonomous AI and what it's capable of, so it's really built on a couple core technologies. One of them is deep reinforcement learning. So this is what came out of DeepMind, which was a Google spinoff. It was around 2015, 2016. And its big coming out was AlphaGo. So this was a program built to play Go, and it ended up beating Lee Sedol, which was he was a Go grandmaster, a human grandmaster, and it beat him. And then they went on to build AlphaZero, which beat our best chess grandmasters, and then it beat our best chess software. So if you think about the decades of optimizations that were built into that software, and it beat it handily. So they were really onto something. They built Alpha Star, beat our best StarCraft players. So they were really onto something. And so what, of course, so then over the years since, people have applied that same deep reinforcement learning to different problems. In this case, it would be industrial types of problems. And why it's significant is that autonomous AI can do, frankly, what our customers think AI can do, which is that it can actually look at the state of a system and say, based on everything I'm seeing, here's your next most optimal thing to do. It's not just going to make a prediction, which is what like supervised learning does. That's kind of the traditional predictive types of machine learning. It will actually make a recommendation. It will actually say, take this action. And what's interesting is if you think about how it's able to beat grandmasters and things like that, it has to be able to build long-term strategy. So it can make decisions that look suboptimal in the short term because it's working towards a long-term, it's working to win the game. It's working towards a long-term, more optimal solution. And frankly, when I start to talk about that with customers, that's what they get excited about. They go, that's what we need, in this industry.
Okay. It's all very well beating grandmasters, but how is this helping us with sustainability?
Yeah. Well, and so what's interesting about sustainability is oftentimes it's just a question of aligning incentives. So we've been working with customers, I've been working with customers for over 20 years now on things like optimizing yield and increasing yield, but also on things like decreasing scrap, decreasing energy usage. In our world, we talk about an acronym called WAGES. So that's water, air, gas, electricity, and steam. Those are the primary utilities, the primary inputs besides labor into almost every manufacturing process. And we've been talking about reducing the consumption of that. Now, again, most customers are probably primarily interested in that because of cost reduction. Besides labor, those are typically the most expensive inputs to the process.
Sure.
But if we can align incentives, the gains in reduction of wages is the same thing that's going to reduce the amount of emissions in the future. So it's really just about aligning incentives.
Okay. And do you have any examples you can talk to where, you've managed to reduce one of the letters of wages or all of the letters of wages and have reduced emissions as a consequence?
Sure can. So we've got a project that we are doing right now. So this is a manufacturer of baby formula. And so part of that process is that you put, big trays of cans, big carts of cans into a steam retort, and it applies steam and pressure to sanitize the cans. Well, the amount of steam that gets consumed by that can be significant. There's also a question of throughput there. So I think they have about 8 retorts that are all working off the same steam generator. And so what we're looking at doing is you need to be able to sanitize the cans, but there's a point where diminishing returns, where you're applying steam, but the cans have already been sanitized. So again, they're looking at steam reduction and they're looking at throughput increase, but ultimately, from an emissions standpoint, from an energy usage standpoint, if we can reduce the amount of steam that's required by sanitizing them just enough, but not more than is necessary, we can increase that throughput. There's also an orchestration problem there, which is really interesting because the system that provides the boiler that provides the steam can't actually run all 8 at the same time. So they've got interlocks, which doesn't allow one steam retort to kick off if another one is using it. So there's this whole dance that we can train an autonomous AI brain. So a neural network trained this way is called a brain. We can train a brain to act like this great coordinator to be able to monitor everything that's going on, only sanitize just up to the curve, just to kill all the bugs and nothing more, and then be able to increase that throughput. But again, also reduce the amount of emissions.
Okay, nice. And you talked as well about reduction in scrap, which seems like a different tack towards a similar output. Similar outcome. Can you talk to me a little bit about that? How does that work? And do you have any examples you can talk to on that one?
I do. I don't know. It's a blessing and a curse to work in the industry that I do because I get to go into these plants and it's absolutely fascinating. I was someone. There's a show, at least in the U.S., called on the Science Channel called How It's Made, and it shows how things are made. And I always used to love that show. And so now, in my career, I get to do that and I get to go into these factories and I get to see how things are made. It's absolutely fascinating. On the downside, though, I do get to see kind of the dirty underbelly of manufacturing. One of those is the amount of waste. Massive, massive amounts of waste, to the point where it's pretty disheartening. If you talk, I get the impulse. I talk to friends of mine, and they're really worried about recycling, and they're really worried about reducing. And I'm like, household waste just pales in comparison to the tons, literal tons of industrial waste that we generate every day. So if we can reduce that, that's a significant win. So as an example of that, and again, it's about aligning incentives. We worked with a drywall manufacturer. And so the current state of the art is that you create these drywall sheets, and then, they go and then you do, there's a destructive test. They take a sample from the drywall sheets, they send it to the quality labs, and it takes about an hour. It could take longer if the lab's at lunch or whatever. It might take 2 hours. So they're still making sheets while those results are coming back from the lab.
Right.
When they finally get it back, they only then realize, well, we've been making garbage. We've been making scrap, and all of this will go to a landfill. And so then they make the adjustments so that they can, get dialed in and start making good sheets.
Sure.
And this process, repeats. Well, we were able to build a computer vision system because it turns out that as the drywall is drying, there's some certain visual indications that we can detect with certain cameras that we can actually predict what the final quality of those sheets is going to be before the hour-long wait for quality. And we're talking, effectively near real time. In minutes, we can tell the operators that the quality is starting to trend downward, and they can make the adjustments in real time to get back to making good product. Now, again, that drywall manufacturer did it because they want to make more product and increase their throughput. But the side effect of that, if we align the incentives correctly, is now we instantly reduce the amount of scrap that this company generates. And the ROI that this company has told us that they're seeing is massive, hundreds and hundreds of thousands of dollars. And then, of course, tons and tons of scrap drywall that they're not making anymore.
Nice. You mentioned as well on the intro call, vertical integration and ways that can help. Talk to me a little bit about that and give me a couple of examples if you can.
Yeah. So we've got a customer right now. They build furnaces and the process for creating glass bottles. And so the process for creating glass bottles, the current state of the art is you have to have a furnace that's about the size of a 2-story building. It's a very involved process. Obviously, a ton of energy is required to do this. Obviously, a giant footprint in terms of the actual building and lots of staff. They are developing a process right now that will it's a whole new way of building glass bottles. And it's so small that it's effectively the size of a couple trailers. And the idea would be that instead of having to make these bottles in one plant and then ship them across the country to be filled somewhere else, this new process is so small that they can basically have it on site. And so a bottler could basically have sand coming in, make bottles, and then fill them right on site. So you talk about all of the upstream, downstream transportation that's required there, all the energy that's typically consumed, all the hours and everything, and then, typically like the cleaning process of these bottles and everything that would not have to happen if you knew that they were pristine, they were coming right off of the line and you could fill them right away. So that's that vertical integration. I think everyone's moving towards that. We've seen more and more metals companies that are moving towards vertically integrated steel mills and aluminum mills and things like that. In the case of that bottle manufacturer, they're actually using autonomous AI then so this thing would ship, they would actually sell this to, bottlers and things like that. And the autonomous AI that we've designed would actually run that system. One of the challenges when you're building something that's never been built before is how do you get operators who actually know how to use it? So in the case of that process, they only have 2 operators in the world, because it's brand new, who are experts at being able to make these bottles. Well, so what we're doing is we're extracting the information from their heads. We're using a process that's also part of that autonomous AI umbrella called machine teaching. That's where we actually take all that expertise from those SMEs and we actually build kind of like a workflow where it says things like it makes decisions on, okay, if the line's running hot, you turn this knob. And if the line's running cool, and this is all expertise that we got out of their heads, but we build it into this graph. And so then when we let the DRL loose on that to learn, it actually can leverage those heuristics, those best practices from the best operators. So for free, you also get this thing that a lot of our customers are asking us for is how can we capture the expertise from our subject matter experts before they retire, before they walk out the door? This technique really is able to do that as well.
So basically you're cloning people.
In the best way possible.
Fantastic. Any other success stories you can talk to about your clients and big wins you've had in sustainability or emissions reductions?
Yeah. So one of the areas that we're applying this technology to as well is we've got a natural gas supplier. They're primarily out of Canada, but they also operate some in the United States. And so we built an AI that can actually predict the amount of demand for their natural gas. So the idea is that it's expensive. It takes energy, and anytime you expend energy, you're increasing emissions. So it takes a lot of energy to move this natural gas, especially if there's unexpected demand. And so now you're taking Herculean efforts to try to get that natural gas to where it needs to be. If instead you can predict a week ahead of time that natural gas needs to be at certain parts of the country, as you would expect, things like, cold fronts and as well as historic demand. And it takes all of that into account in upcoming weather. It takes all that AI takes all of that into account and then says, okay, you need to move this much natural gas to here. So if we can get ahead of that, if we can move that when energy is cheaper and when emissions would be less, we can get ahead of that. And again, I think that's that ability AI has to both decrease costs for our clients, but then also to decrease things like energy emissions.
Nice. And what would you say have been some of the biggest challenges you've encountered in operationalizing technologies for sustainability, and how have you overcome them?
Yeah, well, from an operationalizing standpoint, we're to toot our own horn, because we've got 30 plus years, we've been around since 1989. So because we have 30 plus years experience working in the plant floor, we actually are able to overcome a lot of the objections and a lot of the issues that maybe some of the bigger consultancies or the bigger vendors run into. But we're very good at organizational change management, especially with those people on the plant floor. If you think about it, if you have one of these AI solutions, you've got a model, it's working great, it's predictive, whatever, until it's on the plant floor and until someone in operations, till a supervisor is trusting it instead of their own experience, their own eyes, ears, decades of experience in some cases, until they're using that to make better decisions, you're not seeing any ROI. Everything up to that point was a giant science experiment. So we've been able to leverage that, and really, so the operationalizing piece of it is something that I think we do really well at. The challenges really come from the fact that this is just manufacturing is just a risk-averse industry, and for good reason. And so they tend to be 5 to 7 years behind the rest of the world in terms of adoption of technology. So you run up against that issue, and then you just have companies that are just not that forward thinking. They've been doing things a certain way for a long time. I was reading an article, and I won't mention them by name, but there's been a recent giant acquisition of a US steel manufacturer recently, which has made a lot of headlines. And I read an analysis of it. And the big thing that they said in the article was that this particular company was the last to adopt a lot of the new technologies. Looking back through the history of steelmaking, they were the last one to come to the table. And instead, frankly, we're oftentimes looking for government to bail them out instead of innovating. And now they just got acquired by a giant Japanese corporation. So, if you're looking for my advice to, these manufacturing clients, is that if you're looking to compete with the rest of the world is looking at these same technologies. If you're looking to outcompete them, then we've got to be the country that's first to innovate on these things and first to try these things. There's way to de-risk this stuff. You don't have to bet the farm on AI. There's lots of ways to de-risk these types of projects, but to not go after them at all, to not even, dip your toe in and try some of these things and see what works is probably not the best approach.
Sure. And looking ahead, what emerging technologies or strategies do you think will be game changers in sustainable manufacturing?
Yeah, I think this adoption of, obviously I'm biased because I'm so focused in this right now, but I think this adoption of autonomous AI, I really do see it as an inflection point. I think AI in general, one of the things that gets thrown around a lot is that we're in the fourth industrial revolution, right? So you can look back at all the different the first through third revolutions. And you can see now, well, okay, that revolution was about this. It was about, moving from pneumatics to, transistors and things. And it's hard when you're in the middle of a revolution to know, but I really feel strongly that when we get to the end of the fourth industrial revolution, we'll look back and say, oh, that was to get to AI. When I started my career, we were still talking to customers about recording all the data coming from the plant floor and making sure that you're not throwing away all that valuable data. Now, in retrospect, I'm real glad we did that because AI is real hungry for data, right? So it does feel like we were building towards this AI future. So I see AI as the path forward, but then I think this autonomous AI is a serious inflection point when you talk about being able to perform as well as humans, and in some cases outperform humans and find strategies that human operators and human supervisors wouldn't even see. I think that's a big deal. As far as how that applies to sustainability, I think we're one of the handful of countries that still has a big manufacturing footprint, but also is looking probably the closest at sustainability. There's a lot of developing countries that have, big manufacturing output, but they're, in a lot of ways, they're just trying to make stuff as fast as they can. And, they're not even necessarily looking at the human costs. They're certainly not looking at the ecological costs. So if we can combine our typical, American innovation with AI, as well as our focus on sustainability, I really think that we've got everything we need to move us forward into a sustainable future.
Nice. We're coming towards the end of the podcast now, Bryan. Is there any question that I haven't asked that you wish I had, or any aspect of this we haven't touched on that you think it's important for people to think about?
Yeah, I think my general advice to a company that maybe is thinking about this, is looking at maybe, dipping their toe into it, is to get a system integrator involved. I know that sounds self-serving, even if it's not us. It's that important because when you just trust what the AI vendors are telling you, all they have is a hammer. So everything's got to look like a nail to them. Whereas an independent system integrator can actually look at all of the different platforms that are available, can tailor a solution to what you actually need. And like I said, we've got a lot of capabilities to de-risk these projects along the way. So that you're not spending a ton of money, millions of dollars, like some of the big IT consultancies will ask you to do, and then not really have anything to show for it at the end. So get an independent SI involved. So hopefully someone who's very versed in the plant floor, in that world of operational technology. It's just that important. And then just make the move, do a small project, do a pilot, things like that, but start getting involved in that. Some of the most forward-thinking companies that we're working with have titles like Director of Digital Transformation, VP of Industry 4.0. That to me, when I walk in there and I'm sitting down across the table from someone with a title like that, to me, that's the type of company that, that it feels like a forward-thinking company. It feels like a company that's going to last for a long time and, maybe not get bought out by a giant Japanese, mega corporations.
Fair enough. Good. Bryan, if people would like to know more about yourself or any of the things we discussed in the podcast today, where would you have me direct them?
Yeah, so they can always find me on LinkedIn. So Bryan, BryanDeBois on LinkedIn, or check us out at RoviSys.com/AI. That's the AI section of our website. And I always am happy to talk to anyone.
Fantastic. Bryan, that's been really interesting. Thanks a million for coming on the podcast today.
Thanks, Tom.